Our lesson for today, we are going to look at Mathematics 15.8.1, complex numbers. We are going to look at how to find the argument of a complex number. Let's start. Our previous lesson video, we are looking at how to find the modulus of a complex number. Then we were using this format to find the modulus. So today's lesson, we are going to look at how to find the argument of a complex number. Remember, the modulus, we were calculating the distance or the length of z when we are given a and b in terms of coordinates. So in this lesson, we are going to furthermore calculate the angle. Now let's take one of the previous examples that we had in modulus lesson video, and then let us quickly represent this using a sketch. So we can see that we have 4 and 3. So it's positive 4 and positive 3, which means it's in quadrant number 1. So our z will be here. Then when we want to represent 4, we are going to have it this side. Then when we want to represent 3, we are going to have it this side. Then they form 90 degrees. Then this will be our z. So to find the argument, we are actually looking for this angle. So the argument of z will be theta, but you should take note that our theta must be between this interval, negative pi and less than or equals to positive pi. We know that negative pi is the same as negative 180, and then positive pi is 180. So in this lesson video, we are going to use our radians as our format to calculate these values. That is why instead of 180, I put it pi. So explaining this interval in detail, this will be our positive pi if we take this root, and then it will be negative pi if we take this root. So it simply means that in order for us to have this, we are going to have 4 situations. This will be the first angle, this will be the second angle, and we can see it's still within this interval. Our next one will be like this. We cannot take it this way because we can see that this will not be from 0 to, this will not be 180, it will be greater than 180. Angle from here up to here, it's actually greater than 180. Remember that from here to here, it's 180. So from here to here, it's basically more than 180. So we cannot take it that root. Instead, we are going to take it to this root. So you can see that it's from 0 to, we are approaching negative 180. This is a negative angle. So basically, when it's in quadrant number 3 and 4, 4 is here, we are going to consider negative angles. So we have 2 negative angles and 2 positive angles. Let us explain this in detail, especially the negative angles. Let's say our complex number is in quadrant number 4. This will be the angle that we are going to look for, and it will be a negative angle. Then if it's in quadrant number 3, if this is our complex number, we are going to consider this angle in order for us to calculate this angle theta. We are going to work out this angle first. We might call this alpha. So we know that alpha plus theta, it will give us 180. Actually, it will give us pi. Remember, we are dealing with radians. Now, since it's from this to a negative pi, we are going to put negative here. And alpha and theta, they will also be negative because we are dealing with negative angles here. This also applies when we have something like this. It's in quadrant number 2. We are going to be using this angle as our argument. Then to figure this angle, we are going to use this equation. Alpha plus theta, it will give us pi. So keep these equations. We are going to use them when we're looking at examples. Now, considering the example that we talked about, to find this angle, which is our argument, we are going to use tan theta. It's equals to our b. We're going to take the absolute value of b and absolute value of a, meaning that we only consider the positive signs. So tan theta, it's equals to our b, it's 3/4. Then from here we are going to take the tan inverse 4. Then we are going to get 36.97 degrees, and then when we have this in radians, you're going to have 0.64 radians. So this is our argument. Let us look at another example. Z is equals to 3 minus 2i. So representing this, we can see this is in quadrant number 4. Then this will be our 3. This will be our -2. And then we are looking for this negative angle. So tan theta is equals to 2/3. Theta is tan inverse of 2/3. Then theta is equals to 0.59 rads. But you should know that this is not the argument of this complex number. Since it's in the negative side, I mean it's clockwise, it should be a negative angle. Let's go ahead and find the argument of this complex number, which is complex number W. We can see that it's negative, it's left down, so our complex number is here. Then we have -3, -3. So we are looking for this angle. In order to find this angle, we are going to use this one, alpha. So the argument of W will be equals to pi minus alpha. Then we are going to, since we are moving to the negative side, we are going to take the negative of those. Or we can say theta is equals to the 2. So we need to work out alpha. How do you calculate alpha? We are going to use tan alpha is equals to 3 over 3. So alpha is tan inverse of 1. We get that alpha is equals to 0.79 rads. Then we can go ahead and find the argument of W, which will be negative minus 0.79. The answer is negative 2.35 rads. So this is how we actually calculate the argument of a complex number. This is a continuous lesson video, whereby the first lesson video we're looking at modulus. This is Fahula SJ. Thank you very much.